Alright guys, this is gonna be the last video I make this year for chapter 6. Um, we're gonna add to our similarity toolbox. So we discussed angle, which is really angle, but us math people were like, well, we don't really need to know that second one because of the third angle theorem, so I'm not gonna talk about it. But there's more we can do. Right? So we do a little warm-up, all right, where we can look at this and say, well, 48, what's the complement to 48? It's 42. So clearly 42 plus 90, angle. I like this problem about error analysis because this is going to come up. You're going to have questions like this that are on your test at the end of this chapter, where when you set up 4 over 6 and 5 over x, we're not 5 is not a side of a triangle. It's not. What we need to be doing is 6 over x and comparing that to 4 over 9, right? 4 plus 5 is 9. So this is a great question to be acquainted with because it's something I see people make mistakes with a lot. It's like, oh yeah, I'll just use the 5. The 5 is kind of not that useful. It's only when we take the 5 with the 4 that we get the full side. Okay, so we talked last lesson, angle. It's kind of like congruence, right? Where the idea is, for similarity, technically what I'm supposed to know is I need to know that all the sides are proportional and all the angles are the same. How can we minimize that information and still reach the same conclusions? So typically what I have everybody do is I have people partner up, somebody draws a triangle using some whole number measurements. And then the partner's job is to either like double everything or cut everything in half and try and make their own triangle. We gave you guys a couple minutes to work on it. And then I say, all right, if you have a protractor, what do you think you're going to notice about your angles? And people say, well, they're the same. So the idea is if all the angles are the same, it guarantees that the proportions will be the same. And side is kind of that inverse, where it says, well, if all the sides are proportional, doesn't that guarantee that the angles are the same? Think about where this comes from, right? Side was also a congruency theorem that said, if you know that all three sides are the same between two shapes, they have to be organized in the same way. Like it has to produce the same triangle. So this is kind of the same idea. If they have to produce the same triangle, then if we scale everything up by a factor of 2, of course it's going to be organized in the same way. Like all the angles will stay the same. So looking at these, this is a great one. Like pause and take a look here. And you'd be able to say that, oh, this one is similar because it follows the same proportion. But here, 8 over 8, 16 over 16, 10 over 12. Oh, that doesn't match the rest of them. So it can't work. This is great. It is good to pause here. We talk in our level of class, we don't really do we don't do any proofs. But I try to introduce you to the proofs because it's important to understand that you should never take what I say at face value. You should trust that there's a reason for this, right? That I'm not just saying, hey, write this down. There's a logical mathematical reason behind why this works. So this is a new type of question. It's not that new in that, I could say, hey, these triangles are similar. So what's x? This isn't that different, saying what value of x makes it similar. It's more just hinders on your understanding that in order for these to be similar, all the sides must be proportional through that side theorem. And then therefore you can set those. 4 over 12 gets me my scale factor, and then I can use that on either 8 over 3x plus 1, or 3 times x plus 1 rather, or x minus 1 over 18. Either way, I'll end up in the same place, which is x equals 7. So this finally brings us to our last theorem, side angle side. So the important thing to think about is it's like, in many ways it relates to the hinge theorem. I wish I could show you guys what I normally do in class, which is I'll take expo markers, and I'll be like, if I have an expo marker like this, and then an expo marker like this, and I tell you that we're going to lock this into place. This is another one where side angle side, you're going, is side angle side something that we learned about for congruence? Sure is. When we lock it into place, it kind of guarantees what that third side is going to have to be, right? So if I then attach another expo marker, what have I done? I've doubled it. And then we would find what happens to this distance? It's twice the size of that old distance. So that's the activity we do in class, sort of as a little proof there. At this point, you now have all three. So there's not as many that you need to memorize that prove similarity. So similarity, unless you have all the information, the only time you can make a conclusion about similarity without knowing that all the angles are the same and that all the sides are proportional, the only way you're getting away with that is if one of these three situations is the case. If it's not, you cannot make that assumption. So angle, angle, side, 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 and side angle, side similarity. So there's practice attached to this assignment. We're hurtling towards the end of this chapter, and I hope this video helped.